Acids and bases. A lot of people can tell you that a lemon is an acid and baking powder is a base. But if you ask them what an acid is and how it's made, they can't really give you an answer. I mean, if you were asked how to make a s'more, you would say you take a melted marshmallow and chocolate and then you put it in between two Marie biscuits. That will give you a s'more. Easy, right? Try asking a science teacher to explain exactly how an acid is formed. On the web and pretty much everywhere, you can find information on acids and bases. You'll roughly learn that acids are protons, or H+ donors, while bases are the opposite, i.e. protons or H+ receptors. If you were a learner, though, you'd ask yourself, how does that help me understand what an acid or base is? I can't picture that. Certainly not the simple way I would do a s'more. So where do acids get this property of having readily available proton donors? Acids are made when gas molecules dissolve in water. Some examples: hydrogen chloride, hydrogen fluoride, hydrogen sulfate. You will find that most of them have hydrogen molecules, hence the name H+ donors. When these gases and some others dissolve in water, they make acids. Note that not all gases dissolve in water. You can then ask yourself, where does the H+ donor now come from? There is no mention of atoms being ionized. That is a good question, which leads us into what happens at an atomic level when things dissolve in water. Water is a polar molecule. No, not that kind of polar. Water is a polar molecule, which means it's like a magnet with two poles, a negative and positive pole. This magnetic-like force from the water molecule, when mixed with some substance, attracts the ions of the solute molecules, breaking their bonds in the process. So, for example, hydrogen chloride. The H+ will be attracted to the negative side of water and the Cl- to the positive side. The two ions float around, attracted to the water molecules at a distance, but not bonded. This gives a solution that can readily provide H+ if needed, hence making it acidic.